Assalamu alaikum. Welcome, students. I hope that you and your family are in good health. Now, let's have a quick review of the course outline that will be covered in this semester. We will be covering a total of 9 chapters in this course, as mentioned here. In the first chapter, we will define what a control system is, what are the different configurations of a control system, along with their pros and cons, what are the design objectives of a control system, and finally, we will conclude the chapter by describing the steps involved in the designing of a control system. In the second chapter, we will study the modeling of a system in frequency domain, what are the benefits of modeling a system in frequency domain, and finally, we will apply the tool in analyzing electrical, mechanical, and electromechanical systems by considering examples. Chapter 3 is just the aliased version of Chapter 2, except all the analysis will be done in time domain. In Chapter 4, as the name suggests, we will gonna learn about the time specification of a control system, whether the system is electrical or mechanical or electromechanical. Chapter 5 is devoted to the reduction of large system into a single transfer function. We will see why we are interested in obtaining a single transfer function. Chapter 6 In Chapter 6, we will investigate about how to build or create stable systems. In Chapter 7 is dedicated to the evaluation of steady-state errors of the system under standard inputs. In Chapter 8, we will study how to sketch the root locus and its significance in control system. And finally, Chapter 9 is devoted to the plotting of frequency spectrum and how we can use it to model a system. So that was the preface of the course, which was just discussed. This is the criteria for sessional assessment. There will be a midterm exam, possibly conducted online. I'm not sure about the week in which I will be conducting the exam, as the university is still shaping policies regarding this. But I will inform you at least 2 weeks prior the event. And there will be an assignment which will be submitted at the end of 10th week of the semester. Finally, we have 2 session tests, each having 5 marks. Possibly they will be conducted in 4th and 10th week respectively. Now, these are the 2 books I will be consulting, with this one as the textbook of the course. Now let's start the course formally by defining a system. You must have studied what a system is. You can search for the word on Wikipedia also, just in case. Here you can see the word system has broad meanings and can be applied in many fields like economics or human culture, science, etc. In engineering and physics, the definition is a physical system is the portion of the universe that is being studied. Uh, so we can say anything which is under observation or study will become the system. So now let's define what a control system is. Control system is defined as a system consists of subsystems or processes, or we can say plants assembled for the purpose of obtaining the desired output along with desired performance given a specified input. So in a block diagram, this definition can be represented as a block containing a control system here we have input, or I can also say it as desired response, and finally this represents output of the system, or I can also write it as actual response of the system. Of course, the output or actual response of the system should be as close as possible to the input or desired response. That's what a control system is designed for. but can never be exactly equal to the desired response due to physical limitations. For example, consider an elevator. If we press the button to reach the fourth floor of the building, let's say, the elevator starts to move upward with a speed comfortable for passengers. We can say that will become our design criteria, and after some time it will reach at the fourth floor. We can graphically represent the position of the elevator with respect to time as here a constant set point representing the fourth floor. This will be the elevator location, and this will become time, and here we go. Sorry. This will be our steady state response. Steady state response. This will be the steady state error, and this will be transient response of the system, and this represents input command. Here we can see the push button we press was the input or the desired response represented as the step input in the figure, and the response of the elevator is the actual response of the system after the application of the step input. By looking at the figure, uh, it is apparent that the output response comprises of two responses, namely, you can say output response or elevator response. Output response is equals to the transient response plus the steady state response. The performance of the elevator is dependent on these two responses. Too slow transient response will make the passengers impatient, and too fast will make them uncomfortable. So we can say passengers' comfort and patience is dependent upon this transient response. Similarly, steady state error is also the important parameter, as since steady state error is related to the steady state response, so we can say the steady state response can also become our the design criteria. Steady state error is important because the passenger safety and convenience would be sacrificed if the elevator did not level properly with the floor. So that was all about the definition of the control system. Now, the next topic is the history and application of the control system. This topic will be your assignment to search and study it. The topic has no critical concepts behind, so you guys can cover it on your own. I hope, I suppose. Now, the next topic in the sequence is the configuration of a control systems. There are two major configuration of the control systems as mentioned here. One is the open loop system and the other is the closed loop system. Here you can see the generalized block diagram of both open loop and closed loop system. It starts with a subsystem named input transducer, which converts the form of the input to be used by the controller. Here, for example, in case of AC, the digital set point given through the remote controller is converted to the equivalent voltage, which is then used as a set point of the controller subsystem present in the AC. The controller subsystem drives the process or plant. The plant subsystem is actually responsible for the conversion of input to the output. For example, in case of AC, the plant will be the compressor of the AC as it is responsible for the cooling. The main distinguishing characteristics of the open loop system is that it cannot compensate for disturbances or noises that are being added to the system. The disturbance can be wanted or can be unwanted. Just for the sake of understanding, consider a vessel containing water with a heater containing heater consider that vessel contain water to be heated with an electric heater. We can model an electric heater with a resistor having a large resistance with high power dissipating capability. This resistor has the high power dissipating capability. Let's say the voltage applied to the heater is 100 volts. Resistance is 10 ohms and the mass of the water is 10 kg, and consider that the change in temperature needed is 10 degrees C. Uh, no, we can calculate the power that is being dissipated in the resistor using the formula. I hope you guys have learned it in the basic electrical engineering course. Power dissipated is V square over R. The applied voltage is 100 and the resistance of the resistor is 10. So I get the 1000 watt. So that is the power, that is it's the power being generated by the resistor. Let's say that all of the heat that is generated by the resistor is absorbed by the water in the vessel. So I can write as Q is equals to mc delta T. You guys might be familiar with this formula. Here we have the mass of the water, which is 10 kg. C is the specific heat, which is 4200 joules per kilogram degree C, and the needed temperature rise is 10. So I get the answer 420000 joules. So this amount of heat is required to raise the temperature of the water in the vessel by 10 degrees C. Since the heat generated by the heater is absorbed in the water present in the vessel, so I can write as P is equals to Q over T, which is the definition of power, and 420000 over time is equals to 1000, since the power is 1000, and the T will become 4 to and here we get 420 seconds. So it will take 420 seconds to heat the 10 kg water by 10 degrees C. Of course, we can reduce this time by taking a heater with high power dissipating capability. Now we can design an open loop control system for this heater, which will take the temperature change as a set point and will turn on the heater for the specific amount of time by considering the same system. So let's derive the equation of the required time for any arbitrary temperature change by considering 2 points formula. Here we have 0 comma T1, and the second point is 420 comma T1 plus 10. Now this is the time and this is temperature. This is time and this is temperature. At the start, the heater is off, so here we have 0 seconds. Let's say initially the water is at temperature T1. After 420 seconds, the water will be at T1 plus 10 degrees C. So I can use these 2 points to find out the equation that will relate the time and the change in temperature. So we know that using 2 points formula, y minus y1 is equals to y2 minus y1 over x2 minus x1 and x minus x1. So here y is the temperature and the x is the time. So I can write as T minus y1 is T1 is equals to y2 minus y1, which is T1 plus 10 minus T1, which will be 10 over x2 minus x1, which is 420 minus 0. It will become 420, and the x-axis is time t minus and x1 is 0. Now this T minus T1 represents the change in temperature. So I can write it as del T is equals to 10 over 420 into time, and T is equals to, here they get cancelled, 42 delta T. This will be the required controlling equation. Now this equation can be used to design an open loop system with a temperature set point, which is then converted to time interval using this equation required for the heater to be turned on in order to achieve that temperature set point. Let's say now we add some disturbance in the system by including more water in the vessel. The controller will never be able to cope this disturbance as it has no means to measure this change, and eventually it will stop the heater even when the temperature has not reached to the desired. Also, the unwanted disturbance can't compensate in the open loop system. So it's a major drawback of the open loop system. That's why open loop systems are never used in the critical application where the deviation from desired input cannot be compromised. All the control systems present in the industry are therefore closed loop in configuration. The drawback of the open loop system is well compensated in the closed loop system, also known as feedback control system. It compensates the disturbance by measuring the output response and feeding it through feedback path and comparing it with the input at the summing junction. If there is any difference, the system will drive the plant to make the correction and in the output response. So in the example, of the open loop temperature control system that we just discussed, we can add a sensor that will measure the temperature of the water in the vessel, feeding it back for comparing it with a set point. This configuration will compensate for any disturbance like the one we created by adding more water in the vessel. So let's summarize the discussion we just did by highlighting the pros and cons of both the system. Uh, Pros of open loop system. Uh, First point is open loop system are simple and economic, since there is no feedback path and the design of the controller is also simple. The construction is easier, and the more important, they are stable generally. Uh, Now, the cons of the open loop system. I hope you won't mind my bad handwriting, since I'm still practicing how to use this graphic tablet. They are inaccurate and unreliable. Uh, they cannot compensate the disturbance automatically. Now, let's define the pros of closed loop system. Uh, they are accurate even in the presence of non nonlinearities. Uh, and secondly, they are not affected by noise. The cons of closed loop system. They are costly and complex. Uh, they may lead to oscillatory response. We will see what this term mean, and of course stability is a major concern. So that was all about the configuration of the system. Now, the next topic in our sequence is the analysis and design objectives of a control system. Here, the word analysis describes the process by which system's performance is determined. For example, we evaluated the transient response and steady state error of a system to determine if they meet the desired specification. The word design describes the process by which system's performance is created or changed. For example, if a system's transient response and steady-state response does not meet the desired specification, then we change the system's parameter or add some additional components to meet the specification. So we have three major analysis and design objectives. One is the transient response of the system, second is steady state response, and the third is the stability of the system. So that was all about today's lecture. Now we will start our discussion from here in the next lecture. Thank you.